Dear students, can you tell me what kind of system is this? Is this an open system, closed system, or an isolated system? Well, to answer this question, first we have to understand what are open system, closed system, and isolated system. And even before that, we'll have to understand what is a system. So let us understand what is a system. Now, I have a collection of particles. You can see the um, orange spheres, or you can say the circles, the ovals, yellow ovals, and the blue squares. Now, I wish that I study the blue squares. So if I want to study the blue squares, what I will do, I'll group all the blue squares together and then I will draw a boundary surrounding them. So this becomes my boundary. Now what I have done, I have collected all the blue squares together. Now it is very easy for me to focus on the blue squares and study their behavior. So everything which is within the boundary on which we are doing our study is called a system. And everything that is outside the boundary is known as the surrounding. Now, for me, it becomes quite easy to see if the blue particles, how they're behaving with the surrounding. Are the blue particles going out of the boundary? Are any of the particles from the surrounding coming into the boundary and interacting with the blue particles? Are the blue particles transferring energy to the surrounding particles, or the surrounding particles, are they transferring energy to the blue particles? That way, it becomes very, very easy for me to carry out my study. Now, let us take an example of the jet engine. Now, in the jet engine, suppose the jet engine has many different parts, right? We have the compressors, right? The compressors, we have the combustion chambers, we have the turbines, and we have the exhaust, right? So if we want to study, say, the behavior of the particles, right, in the compressor, then we can choose a portion of the compressor or the entire compressor as our system. If you want to study what is happening in the combustion chamber, so we can simply select the combustion chamber as our system. We can draw a boundary across the combustion chamber and that becomes our system, and everything else becomes the surrounding. And if you want to study the entire jet engine, the performance of the entire jet engine, what we can do, we can actually select our boundary, right, to cover up the entire jet engine. And that will become our system. So depending on what exactly you want to study, you will decide your boundary. Boundary is a hypothetical surface which are decided by us so that we can focus on the area that is meaningful to us, right? So I hope you got what exactly is the system, what is the boundary, and what is surrounding. Having said that, there are possibilities to classify a system into open system, closed system, or an isolated system, depending on how matter is interacting with the system and how energy is interacting with the system. Let us take the example of a bottle containing hot water. Now, initially, you can see the bottle is open. Now, if it is open, can you pour water into the bottle? Yes. Can you take out water from the bottle? Yes. Means hot water, the bottle, mass transfer, initially the mass transfer is possible. Now, if you touch the bottle, what will you feel? Even if you don't know the water inside the bottle is hot or cold, by touching the bottle, you'll get to know. You'll feel the heat of the water inside, isn't it? What is happening? Energy is getting transferred from the water inside to your hands. Means energy transfer is also taking place. So such a system where energy transfer is possible, mass transfer is also possible, are known as open system. Now, let me do one thing. I take up a cap and then cover up the bottle. I close the bottle using a cap. Now, what do you think will happen? Can you still take out water or put water into the bottle? No. So the mass transfer is not permitted now. Can we transfer energy? Let us check. Simply touch the bottle. Will you be able to feel the heat? Yes, of course. It means energy transfer is still possible. Such kind of systems are known as closed systems where matter transfer, mass transfer is not possible, whereas the energy transfer is possible. Now let us take the example of an isolated system. To take this example, first what we are going to do, we are going to cover up this bottle with some insulating material. Let us cover this bottle with some insulating material. Now once you cover this bottle with insulating material, right? Now let us try to do our analysis. Now can we transfer mass into it? Can we pour water or take out water from the bottle now? Obviously not. The cap is still on. You can see the cap is still on, right? Now if you touch the bottle, will you be able to predict if the water inside the bottle is hot or cold? No. Because you have an insulating material, you'll not get to know if the water inside is hot or cold. Means energy transfer has also stopped. Such kind of systems are known as isolated systems. Now, practically, it is very difficult to design a isolated system, but many a times we need to study the isolated systems because it simplifies our process. Right? To simplify complicated process, we assume many systems to be isolated systems, and the answers that we get by such an assumption are approximate answers. But if the approximate answers are not causing any difficulty in our design, right? It is not giving high margin of errors, then it is fine. Now let us consider the question that I asked you initially. What kind of system is this? Now you can see this is a container and there are some particles inside it which is having a random motion, right? It is blocked by a piston, right? Now since it is blocked by a piston, can mass transfer happen? No. Mass transfer cannot happen. Now, can heat transfer happen? Now, I have covered the system. Now, what is the system here, first of all, right? First, you have to decide the system, right? So, if you are studying the particles, right? So, this becomes our system. So, you take an imaginary boundary across these particles. I want to study the behavior of the particle, how the particles are behaving. So, this becomes our system, right? We took up the boundary, right? And so, inside the boundary is our system. And everything outside the boundary, right, including the piston, insulating material, everything is surrounding, right? Now, if I consider, right, since I have applied the insulating material, now can you tell me, is heat transfer possible? Can any heat go inside or any heat come outside? No. Can mass go in or come out? No. It means that mass transfer is not possible, heat transfer is also not possible. But wait, heat is just one form of energy. Can we still transfer some energy? What do you think will happen if we push this piston down? Can we push this piston down? Yes, definitely we can. Now, if you push this piston down, you'll see that the particles, our study, is getting compressed. So definitely energy is being transferred using the piston into the system. So though here heat transfer is zero, right? Mass transfer is also zero, but energy is getting transferred into the system through work, right? So can energy, heat transfer is not possible, but energy transfer in form of work, sorry, right, is getting transferred. So what kind of system is this? This is example of a closed system. The point that I want to make here is that while looking at a system, is if it is a closed, open, or isolated, we have to look at three things. Is mass transfer possible? Is heat transfer possible? Is energy transfer through work or any other form possible?